Greetings, epistemophiles. So you want to build your own computer. Why wouldn't you? It's awesome. Sometimes you can save some money building your own computer. Sometimes. You can definitely get better parts than you can with a pre-built computer. But perhaps the best reason for building your own computer? Bragging rights. That's right. Not everybody can build a computer, but you can, even if you've never done it before. And I am going to show you how to do it. I'm going to start by showing you how to select your parts, making sure that those parts are compatible with each other, making sure that you choose parts that are sufficiently powerful for your needs. I'm going to show you how to put all of those parts together, how to install the operating system, and how to install the drivers. So if you've never built a computer before, or if you're just looking to brush up on your skills, this is the video for you. Let's get to it. So the first thing we need to do is determine how much computer do we need? How much power do we need? So choosing components that meet our needs is going to be the first step. The CPU is the brains of the computer, and it will have a bigger impact on the speed of the machine than any other component. So we should probably talk about that first. There's really two major brands of CPUs that you can get for a computer, AMD and Intel. AMD makes a series of processors called Ryzen. They come in different models, a 3, a 5, a 7, and a 9. The lower the number, the slower the processor. Also, the lower the number, the cheaper the processor. So you got to pay for more power. Makes sense. Intel's processors follow pretty much the same model convention. 3, 5, 7, and 9. And once again, the lower number is the slower processor and the cheaper one as well. So what you need to do is figure out how much processor do you need. Chances are you probably already have a computer and your current machine is a good starting place. If your current machine is too slow, then you know you need something faster than that. So what we need to do is we need to look up what processor you have and then compare it to other processors so that we can choose one that's faster than the one you've got now. So to find out what kind of processor is currently on your computer, here's what we're going to do. We're going to press Control, Alt, and Delete on the keyboard all at the same time. Then we're going to select Task Manager. You're going to go to the Performance tab, and up here in the upper right-hand corner, you'll see the name of your processor. If you've got an older version of Windows and it doesn't display that information here, here's another way that you can do it. You're going to click in the search box at the bottom of the screen and type in the word Device. And you're going to launch the Device Manager. Here's a list of all the hardware that's in your computer. Open up the Processors tab, and it will tell you right there what kind of processor you have. Here, this processor has multiple cores, so that's why you see it showing up multiple times. Now that we know what kind of processor we have, we're going to compare it to other processors on the market to find one that is suitable for us. We'll open up the browser window and we'll do a Google search for processor benchmarks. I find that this website right here, tomshardware.com, has a good benchmark page. I'm going to click on that and scroll down. Here you can see some of the more modern CPUs currently on the market, and you can see how they perform with one another. What's nice about this is it shows you both Intel and AMD processors. Note that the AMD processors are called Ryzen and the Intels are called the Core i9 or whatever. And you can see that the Ryzen 5 is slower or lower on the list than the Ryzen 7. Likewise, the Core i5 by Intel is going to be slower or lower on the list than the Core i7. The higher the number, the faster the processor. So you can use a chart like this to at a glance get a feel for how your processor compares to other ones. Now, if your processor is quite old and isn't showing up on this list anymore, then you can search for the specific model number and maybe get some information that way. If you find a processor on here that you're interested in, you can compare your current processor to the new one that you're looking at to see how they compare. So for example, if I do a search for my old processor, which was the 8700K from Intel, and I compare it to the new processor that I'm interested in versus 13900K, this CPU user benchmark page has some pretty good comparison results. So here you can see that my old processor, of all the processors that are currently available, there are 1,369 processors in this database, and my old processor ranks 91 out of 1,369. Not too bad. But the new processor that I'm looking at ranks first. Yes. more power. One thing to keep in mind with processors is that the same naming conventions have been in use for many years. So for example, I could buy two Intel i5 processors, and one of them would be significantly faster than the other. The reason why is because the slower one is older. It's a previous generation, we say. For example, the Intel processors, the latest generation as of the making of this video is the 13 generation. My previous processor was an 8th generation. So if I were to buy an 8th generation i7, which is what I had before, and a 13 gen i7, even though they're both i7s, the 13th gen will be much faster simply because it's newer and the technology used in it is newer. So when you purchase your processor, make sure that you look at the model number, not just the i5 or the i7 name. For Intel, the 8700, that first number tells you the generation, 8700. 13700 would be the 13th generation. Now you might say, oh, well, that 700 means that it's an i7 processor, right? Not necessarily. There's some fudge with the second part of the model number. Some processors will also add a letter at the end of their model number, and that could indicate a number of things, like, for example, whether or not it has built-in graphics capabilities on the CPU itself. You could save a little bit of money by getting one that doesn't have that built-in graphics capability, but it might be worth it to get that functionality just in case you need it. So let's say that we've now compared the benchmarks and we've got both the type of processor we want and the specific model or generation number that we want to get as well. Now it's time to pick a motherboard that is compatible with that. Now, different processors, even if it's an 8th generation i5 versus a 12th generation i5, just because they're both i5s doesn't mean that the pin configuration on the bottom of the chip is the same. And in most cases, they will be different. So we call this the socket, and you need to get a motherboard that has a socket that is compatible with the processor that you want. Select your processor first, and then select a motherboard that is compatible with it. So if I want a 13th generation Intel processor, let's find out what kind of socket that uses. Google. I'm going to type in the model number of the processor that I'm interested in, the 13900K, socket type. Right here it says it uses a socket 1700. So when I'm searching for motherboards, I want to make sure that I choose a motherboard that has that type of socket. So there's all different kinds of motherboards out there from all different kinds of manufacturers. And everybody will have their own preferences and so forth. So for me, I only put Asus motherboards in my computer builds. I've been using them for years and they've never let me down. There was one time where I decided to use a motherboard from a different manufacturer, a big name brand manufacturer, and it was a very unstable machine. So from that point on, I was like, I'm not going to waste my money with anything else. I'm going to go with what I know works. So Asus, for me, I highly recommend them. Even if you know that you want to go with a specific manufacturer, that company might actually make several different kinds of motherboards that all have the same kind of socket. They're all different price levels with different features and so forth as well. Just like with the processors, those different tiers of features are going to cost different amount of money. So make sure that you factor that in. You don't want to get a board that is unnecessarily expensive if a cheaper board is going to give you all the features that you want. So what kind of features do you need? One of the key things that you want to look for in the motherboard is what kind of RAM it takes. So RAM has speed associated with it, and that speed is measured in megahertz. The larger the number, the faster the RAM will be. DDR3, if you're doing a very old build to try and save some money, DDR4 will be faster still, and then the latest RAM as of the making of this video is DDR5. It has traditionally been pretty expensive, but it seems to be kind of coming down now. So I wanted to get a motherboard that took advantage of the DDR5 RAM. So that might be one of the things that you look for, is what type of RAM does this board support. So if you're not really sure what features you want in a motherboard, one thing you can do is you can look at all the different motherboards that are available, take a look at the prices, and then do a comparison. Say, do a Google search for something like, what's the difference between Model A and Model B for this particular manufacturer? And if you find out what the difference between those are, then you can do a little bit of research like, what is this thing? And then determine for yourself whether or not that thing is something that you want, something that's worth that extra money to you. So in doing my research, I discovered that this motherboard, the Asus Strix Z790E gaming Wi-Fi motherboard, that's a mouthful, it offers the 1700 socket that I need for my processor, and it also offers the DDR5 RAM as well. It's got a couple other features that I liked as well that are kind of beyond the scope of this video. So now that I've decided that I wanted to take advantage of that faster DDR5 RAM, we have to choose an actual RAM chip that will be compatible with this motherboard. So we already know that this motherboard is compatible with DDR5, so I should be able to buy any DDR5 RAM. However, I've got a pro tip for you. If you go to your manufacturer's website, in this case Asus, and I look up this particular motherboard that I'm interested in, they're going to have a place on their website where they list all of the parts that have been tested and certified with this board. If you buy RAM from that certified list, you will have an exceedingly stable machine. So that's my number one tip in this video. Get RAM from the tested list. Let's go ahead and I'll show you how to do that. I'm going to Google the motherboard that I'm interested in. Here I'm going to click on the support tab, and I'm going to click on this option for CPU memory support. I'm going to click on the memory tab, and I'm going to be presented with a list of all the different RAM modules that have been tested and certified with this board. So what we want to do is we want to look at this list and we want to price out a few of these. If there's a specific feature you're looking for, like, hey, I'm going to have a glass window in the side of my computer, so I want the RAM to look cool in addition to being functional. Maybe that's one of the things you want to look for. Maybe you want certain lighting on your RAM chips or something. So what I'm going to do is I'm just going to copy some of these model numbers, paste them, and then see how much they cost. I'll go to a couple of vendors and say, hey, this one is 529 bucks. It's, how fast is it? 6,400. That's faster than I need, and that's a lot more money than I want to pay. So I'm going to choose a DDR5 set that is slower than this so that I can save a little bit of money. Just like with our CPUs, there's basically two big names in the graphics card industry, AMD and NVIDIA. You know, ideally we'd buy the best card on the market and we'd have an awesome machine, but most people aren't going to need that. If you're doing a lot of gaming, then you'll want to spend more money on your graphics card, even if it means sacrificing some power in some of the other areas of your build. Your graphics card is going to give you the most bang for your buck for your gaming experience. For me, I don't really do much of any kind of gaming. I just do a lot of video editing. So since I edit with Adobe Premiere, that software is optimized for the CUDA cores that are part of the NVIDIA line. So that pretty much rules out AMD for me altogether. So I already know that I want an NVIDIA card. And I just got to figure out how much power do I need. Now, my video editing software will use some of the capabilities of the graphics card, but the CPU is going to give me the most bang for my buck. So I'm opting to spend more on the processor and a little bit less on the video card. I'm going to type in graphics card benchmarks, and once again I'm going to use Tom's Hardware for this. Scrolling through here as of the making of this video, we can see that the GeForce RTX 4090, this is an NVIDIA card. NVIDIA calls their cards GeForce, and AMD calls their cards Radeon. The 4090 is currently the best one on the market. And as we go down from there, we're going to decrease in power, and we're also going to decrease in price. So if I've opted to go for the RTX 3070 card by NVIDIA for my build. It's the last generation. The 3000 series has been around for a couple of years already. They just came out with the 4000 series. The 4000 series cards are extremely powerful. but they're also quite expensive because they're the newest, greatest thing. So I'm actually able to save a little bit of money by getting a last generation card, and the 3070 should be more than sufficient for my needs. But if I was a gamer, I'd probably want to go for something a little bit more, maybe a 3080, or if I've got deep pockets, maybe one of the latest and greatest generation 4000 cards. But for me, I want to manage performance with price. 3070 is going to be a good match. We're going to need a power supply to power all this stuff. The CPU and the GPU are going to pull the most power in your system. You can do a Google search for power recommendations for whatever processor you're interested in, and power recommendations for whatever video card you're interested in, and that will really steer you in the right direction. Probably anything about 750 watts is going to be sufficient for most builds. If you're going for something extremely high-end with the latest generation GPU and the latest generation CPU, then you're probably going to want to push that up to around the 1000-watt mark, especially if you're planning on overclocking and other stuff, but that's beyond the scope of this video as well. So for me, I actually got a really good deal on a 1300 watt power supply, which is way more power than my system is going to need. But what's nice about this is that the power supply, even if it says it's 1300 watts, it's not going to actually pull 1300 watts out of the wall. It's only going to pull what is demanded from it by the system. As a matter of fact, if you put a power meter on your computer once it's all built, you'll see that its power demands are fluctuating all over the place. After building my new computer, it seems to idle right around 100 watts. So just sitting there, it's pulling 100 watts out of the wall. And when I really start to push it, it jumps up to about 350 watts. But 350 watts, and I've got a capacity of 1300 watts, that might very well be the last power supply I ever have to buy, because I've got plenty of room to grow. Power supplies really aren't that complicated. What you'll want to do is, now that you've decided what motherboard you want, go ahead and download the user manual for that motherboard. And in there, there'll be a section that talks about the power supply. Whatever kind of power supply it says that it needs, go ahead and get one of those. It's probably going to be an ATX power supply, which has been around for a long time. Now, our processor is going to generate a lot of heat, and we're going to need some kind of cooling solution for that. The older processors used to come with a heat sink already, but I've found that a lot of the newer ones, they're not doing that anymore. So you're going to have to buy your own cooler. You basically have two options. You can go air-cooled or you can go liquid-cooled. An air-cooled system will use a big metal thing. It's called a heat sink, and it will have one or more fans attached to it. And the idea is that the heat will go into these metal fins, and the fan will blow cool air across those fins to blow the heat away and therefore cool the processor. A liquid-cooled system will work basically the same way, except the metal thing is filled with fluid, and that will dissipate the heat more efficiently than air does. Now, a liquid-cooled system does run the risk of potentially springing a leak one day, so it's something you want to consider. I've been using liquid-cooled systems for several years now, and I've never had a leak, but that doesn't mean that it's not possible. For my build, I've decided to go with a liquid-cooled system. And this isn't super complicated. You just need to make sure that you get one that is compatible with the socket of your CPU. So once again, you have to know what kind of CPU you're going to have before you choose a cooler for it. Now, a lot of these cooling devices, whether they be air-cooled or liquid-cooled, will fit a variety of different kinds of sockets. They achieve this by shipping the unit with several different kinds of nuts and bolts and attachments that will work with different kinds of sockets. So when you go to assemble yours, make sure that you read the manual that came with it so that you are using the right nuts and bolts for your particular socket. So we've got motherboard, CPU, RAM, power supply. Let's talk about hard drives. So there's a variety of different kinds of hard drives that you can put in a computer. A hard drive is where you're going to store all of your actual data, the operating system, all your files, and all your stuff. So there are basically three different kinds of hard drives. There's the old school ones that have like an actual spinning platter inside. Those are quite slow. speed of the hard drive is very important, and it's one of the things that can really improve the overall performance of your computer as a whole. And when you double click on an icon to launch a program, the code for that program has to be read from the hard drive, and then it moves into the RAM. And once it's in the RAM, then it goes between the RAM and the CPU, and everything moves along really quickly. So the process of actually getting that information off of the hard drive and into the RAM, that's what takes a little while. So if you have a fast hard drive, it won't take very long at all, and you'll feel the difference in terms of a performance increase. So those spinning platter drives are the slowest option, but they're also going to be the cheapest option as a result. The next step up from there would be a solid state drive. They're about the same size as a small hard drive, like a laptop hard drive. They're quite fast, and they can store a lot of data. So that's a very good economical path to take. The fastest option is going to be what's called an NVMe drive. It's just a little tiny like computer chip that plugs into the motherboard itself. Those are the fastest options. They might not have quite as much space as the other types of drives, and per gig you're going to pay a little bit more for them, but you're going to get a significant performance increase out of them as well. So if you want to optimize the speed of your system, an NVMe drive is the way to go. One thing that people sometimes do is they'll spend a little bit of money to get a small but very fast NVMe drive, and they'll install their operating system on that. Then they'll get a slower, larger drive that they'll store all of their files on. So that way the operating system itself moves along nice and quickly, and then all of your other stuff can have a little bit of a lag time that you're sacrificing in order to get a larger amount of storage. So that's an option for you as well. Of course, you're going to need a case to put all of this stuff in. Choose whatever kind of case you want. The thing to keep in mind here is you want to make sure that your case and your motherboard fit together. So if you get a motherboard, a full-size motherboard, we call that an ATX motherboard, and it will fit inside of an ATX case. But they have like mini-sized motherboards as well that will fit in smaller cases. So if you want a smaller machine, you must also choose a motherboard that will fit in that type of case. So make sure that you look into that before you pull the trigger on a case, only to find that your motherboard doesn't fit in it. Other than that, it's going to be a matter of preference. Do you like the aesthetics of how the case looks? Do you want a window in the side so you can see all the parts? Do you want it to be all solid? Do you want glowing lights? And it's your call. The last thing you might want to think about is whether or not you can recycle some of the old parts from your old computer. Some commonly recyclable parts is the case itself. You might be able to reuse your power supply, and you might be able to reuse your hard drives as well. So if any of those parts are still good and meet your needs, then you might be able to do a part transplant. If you do decide to get a new power supply, make sure you do not use the cables from your old power supply. The cables that come with power supplies are, even though the plugs might physically fit, it should not be assumed that they're compatible with each other. So if you do swap out your power supply, get rid of your old one and all of the cables that went with it. Your new power supply will come with its own cables. Make sure you only use those cables. You'll most likely be able to recycle your old monitor, your keyboard, and your mouse as well, unless for some reason you want to upgrade those parts. If you intend to keep your old monitor, make sure that you check the specs for your new video card to make sure that it has a port that is compatible with your old monitor. So for example, if you've got a really old monitor that uses a VGA cable, make sure that your video card has that VGA cable as well, otherwise you're not going to be able to hook them up. You're going to be hard pressed to find a modern video card that has VGA, so if that's the boat you're in, it might be time to look at a new monitor as well. And that's it. So now that we've done our research and picked out our parts, it's time to order them and start assembling. It's time for the moment of truth. I have had these parts sitting on my desk for well over a week, almost 2 weeks, and I finally get to open them. I am so excited. Okay, so let's go ahead and let's bust this bad boy open. If you don't have an anti-static pad, you can set it on top of this this plastic that it comes in. This is an anti-static plastic. Okay, we're going to start by installing the M2 drives. Those go underneath these heat sinks. So this particular motherboard has 5 slots for M2 storage. And so the question is, which port should we plug this into? So this is my primary storage drive, and you can see printed right on there, this is a PCIe 4.0 NVMe drive. So because it's a 4.0, we want to plug it into a 4.0 slot. Now, 4 out of the 5 slots on this board are PCIe 4.0, and one of them is 5.0, the one that's under this big heat sink with a thermal pipe and all this extra stuff. So I am not going to put my primary drive in the 5.0 slot. I'm going to put it in the 4.0 slot, and I'm going to use this one right here. This is slot 2. There's another slot on this side. I have 2 NVMe drives, but I'm only going to plug one in on under this heatsink. That way it'll have the entire heatsink to dissipate heat. This is storage slot 2. So to do this, I have to remove this screw and that screw. So let's go ahead and do that first. So how do I know that this is the 4.0 slot and that this is the 5.0 slot? Because it's not labeled here on the board. It doesn't say which one's 4 and which one's 5. So it's the manual. The manual tells you everything you need to know. Which one of these slots is what port. So I know people don't like to read the manual, but that's just pride talking. Don't let your pride get the better of you. Proverbs 11:2 says, "When pride comes, then comes disgrace. But with humility comes wisdom." Read the manual and you'll have the peace of mind of knowing that you're doing it right. There is a little notch right here that corresponds to a notch on the motherboard as well, so you want to make sure that you're putting it in the right way. If I were to put it in upside down, the notch wouldn't line up, so pay attention to what you're doing. Just going to slide this guy in, and it goes in at a little bit of an angle, so you slide that in like that, and then see how it's a little springy. So you need to push it down. Now another thing that I read in the manual is on my old motherboard there was just a screw. You would screw this down. But this motherboard has this weird little plastic tab thing. Yeah, you twist this little lever here to lock that in place. Until it locks just like that. There. So that's kind of cool. You don't need screws anymore. You just twist the little nub. So that's another thing that I wouldn't have known what that was unless I read the manual. So the next thing you want to do is on the heat sink, when we're going to put this back on top of here, you want to make sure there's this like a rubber film. You have to take off this film first, and there's this pad. This is a thermal pad. You don't want to remove the pad, just this blue plastic film that's on the pad. That will allow the drive to dissipate heat more efficiently into the heat sink. I don't want to touch the film or anything, and just going to line up the little screw holes and try and seat that guy right in place without having to wiggle him around too much. The other NVMe drive that I have, this is just a 250 gigabyte drive. I'm going to plug this one into slot 3. So the question is, which one is slot 3? Going to look at the book, and we see that slot 3 is the one above the middle PCIe slot. We're going to plug that other drive into this one here. So the reason that I chose this configuration, because really it wouldn't matter, they're both 4.0 slots. Why didn't I plug this drive into this one? The answer is this one had a larger heatsink, so I wanted my primary hard drive to take advantage of the larger heatsink for greater heat dissipation. It is a new day and we're ready to unbox the processor and get this installed. So this is the Intel 13900K i9 processor. I'm very excited about this. I've never had an i9 processor before. I feel like I'm moving up in the world. So yes, this is a rather odd looking case. Let's go ahead and get that open and see what this looks like. So, the box self-destructs upon opening. The processor is inside of this thing. Oh look, that opens just like the dust cap on my telescope. So there's the processor right there. So let's go ahead and get this installed. We're ready to install the processor. The processor goes in this spot right here. You should be using static precautions. Obviously we talked about that already, but the CPU is like the most sensitive component for static electricity. So make sure that you have your static strap on, or at least touch something that is grounded to discharge all your free electrons before you take that thing out of its case. You'll notice that the socket release lever has this little plastic thing. That is packaging material, and according to our manual, because we read our manual right here, it says that we are supposed to remove that packaging material. Ensure to remove the CPU socket lever protector on the lever switch before locking the lever switch under the retention tab. Failure to do so will cause damage to your system when installing the cooling system. And it says it again over here. Ensure to remove the CPU socket lever protector. Failure to do so will cause damage to your system. So the reason that I mention this is I watched a video just this morning about a guy who had this exact same processor and an Asus motherboard. It wasn't this kind of motherboard, but it was an Asus motherboard. And it had this piece on it as well. And he did not remove that thing. I noticed it in the video and I was like, see, he didn't read the manual. So that's why we read that stuff, because we might miss that little detail. It would be easy to miss. So the way we do this is we push this down and swing it out, and then we're going to take off that little silicone packaging material. And you want to make sure that you don't unlatch that and just let go of the spring. It is spring loaded. It will fly back. It might break something. So make sure you keep your finger on it when you release that. Flip this little door all the way open like this. There is our CPU socket. If we look carefully at the processor, you'll see in this corner that it has a little triangle right there. And you can even see that same triangle printed on the circuit board as well. See these other corners, they just have little dots in the corner, but this one has a little triangle. So this is to help you orient the processor properly and make sure that it's not upside down in the socket or something. So keep an eye on that. Triangle's in the lower left-hand corner. We're going to look back at our motherboard, and I'm just going to close this door real quick so that you can see that on this little plastic cover there's a triangle in that corner as well. So that is telling us that the corner of the processor, the triangle in the processor, goes in that corner. So let's go ahead and drop that guy in. You want to make sure that you are holding the processor by the edges. You do not want to touch the little contacts on the underside of the CPU. So make sure you're holding it by the edges like this. You'll notice there's these two little plastic tabs, one here, and there are two more on the bottom. You can't see them here because that door's in the way, but those little plastic tabs, that one and that one, line up with notches on the CPU's circuit board. So this ensures that you've got it aligned properly. If it was a little askew inside of the socket, you might not notice it, it wouldn't be seated properly, and you might damage it when you close that door on it. So make sure those little plastic tabs align with the circuit board on the CPU itself. We're now going to close the little door, and we need to remove this plastic cap. we go. And you can see these little metal tabs hold the processor in place. I'm going to bring the little latching arm back down. And we're going to secure it underneath its little locking tab. All right, our processor is installed. It is now time to install the RAM. I have 2 sticks of 32 gigabytes each for a total of 64, and I have 4 RAM slots. So you might be tempted just to pop them in anywhere, and it will probably work, but you'll be leaving some power potentially on the table here. So the way this works is that this is a dual channel motherboard. So even though there are 4 slots, the RAM talks to the processor. There's basically like 2 freeways that come to the CPU to deliver information back and forth from the RAM. So if you put a RAM chip in one slot and you put the other RAM chip in the other slot, and those slots are on the same freeway, well, you can imagine you now have more cars on your freeway, and when there's too many cars, you start getting a traffic jam, right? So what we want to do is we want to put one of our RAM chips on one freeway and the other RAM chip on the other freeway so that they don't interfere with each other. So we get maximum travel to and from the CPU. So the question is, which two of these slots do we need to do to have them on separate channels? Every motherboard is different, so don't assume that because my motherboard is this way that yours will be too. In fact, there are some motherboards that are 4-channel motherboards, and each slot is on its own freeway, so it doesn't even matter how you do it. But for this one, if you have one chip, you should use that second slot. Well, I have 2 chips, so it says I should put one of them in this second slot, and I should put the second one in this end slot here. If you had 4 chips, then you'd fill all 4 bays. 2 of them would use one freeway, and 2 of them would use the other freeway. So let's go ahead and do that. We're going to put one in the second slot and one in the 4th slot. This is a DDR5 RAM, and this is a DDR5 motherboard. You can see that there are a number of pins on the bottom, and there's a little notch right there in the middle. This notch is in a different place for different kinds of RAM. So here you can see that the notch on the DDR4 and the notch on the DDR5 are in slightly different places. That is going to be, that is by design so that you don't accidentally put DDR4 RAM in a motherboard designed for DDR5. So if you do try to plug your RAM in and it is not going, do not force it. One of the things that we want to look for here is that there are these little plastic tabs. And just on one side, on this side, the tabs are fixed, but on this side, they're little locks. So you can flip these little tabs back. I'm going to flip both of these back like this. And they have to be in that position to accommodate the RAM. So we're going to put this in. We're going to slide the one side into this little notch here. The other side's going to go into the corresponding notch on that side. And we're just going to push this straight down. And we're going to make sure that that little tab is lining up with the slot. If it doesn't, then you need to turn the RAM stick around. You got it in backwards. So we're just going to push this straight down, and when we do, that little latch that we pulled out, we push that latch in that direction, it's going to automatically latch itself in. Straight down, even pressure against the entire back. And you can see how that switch engages itself. If it doesn't quite go all the way, then you can give it a little bit of help once you got that seated. All right, we're going to do the same thing with the next DIMM. We're going to push this down. I'm going to apply even pressure on both sides so that it goes in nice and straight as I can get it anyway. That tab automatically engaged. Give it a little bit of help just to make sure that it's fully seated, and we're ready to go. All right, here is the radiator and the pump, and you can see that they are already it's already pre-filled with the fluid, and the tubes are already in place and everything, and this is a lot of stuff to drag around. That's why I'd ideally like to install that after the motherboard's already in place. This particular cooler can accommodate several different sockets, so they've provided hardware for all the different kinds of sockets. So we definitely need to find the manual. I'm not seeing it in here. Maybe it's underneath. I'm not seeing the manual? It is time to panic. There is no manual. There are no instructions to be found anywhere. I've checked the entire box. I've looked under it. I've looked in it. I've looked everywhere. There's nothing. A list of the included parts would seem to indicate that instructions should be present, but they are not here. I thought I could figure it out, but the box contains slightly more than 1 billion screws for all different kinds of sockets. And I don't want to use the wrong one to mess this up. So what I need is a place where all of the world's information is stored. A library? No. A book? No. The internet? Yes. I have located the instructions online. Crisis averted. I just hope that no other parts are missing. According to the instructions, there's a back piece that you need to install first, and then some screws go through the front of the motherboard into that back piece. I'm going to go ahead and install that first because that will be easier to do when it's not in the case, and then we'll mount the entire motherboard into the case after that. So we have the proper standoffs, we have the backplate, and some other assorted hardware that we'll probably be using to attach the fans and stuff, so we'll put those aside for now as well. This part goes on the back of the motherboard. These standoffs go through the front of the motherboard into these little nuts. Here we're looking at the back of the motherboard, and we can see up here at the top, this is the where the back of the CPU is, and we can see our 4 mounting holes in here as well. Here we're looking at the back of the motherboard again, just an extreme zoom. I need to get this mounting bracket. I need to get those little pegs to go into those holes, the further out hole. And this is actually a little trickier than it looks. I think I've got these little nuts pushed out into the right position. So now we're going to just remove the backing, take that off, and we'll see if we can drop that guy in place. That sticker actually is going to help hold this in place a little bit so that when I turn the motherboard around and try to bring the screws up from the other side, it's not going to move around on me. So here we can see the standoffs in each of the corners for that bracket protruding through the motherboard. We're going to take out the standoffs for the 1700 socket, and we're going to screw those into place. All right, what I've done is I've laid the case on its side, and I'm going to lower the motherboard into this. I believe that will be easier than trying to put it in vertically, because then I won't be fighting against gravity. This is a little tall, awkwardly tall. There we go, that's a nice height. There are a number of screws located all around the perimeter of the motherboard, so we're just going to go ahead and seat those down. Now, I recommend that you don't tighten these all the way down. Actually leave them a little bit loose at first. That will allow you to kind of move the motherboard around in case some of your screws, some of your standoffs aren't lined up with all of your holes, and give you a little bit of wiggle room. Once you got all of the screws in place, then go ahead and go back and tighten them all the rest of the way down. Now we're going to go ahead and flip the case vertical so that we can remove the screws for this fan. We'll probably take this one out as well. We need plenty of room for the radiator to go up here in the top. The screws for this are in the top of the case. So according to the manual, we want to install the fans underneath the radiator, and we want to configure them so that they suck in air from the outside into the case like this. And if you look closely at your fans, someplace on them is likely going to be two arrows. One arrow is going to point off to the side. That's going to tell you the direction that the blades are going to move. So these ones are going to move in this direction because the arrow is pointing in that direction. But then the other arrow is going to point either down or up like this. That's going to tell you the direction of the airflow. Then we're going to have to mount it to the bottom of the radiator, and then the radiator to the top of the case like this. One thing worth noting about this is the Corsair H100i Elite LCD cooler. And one of the things that I think is pretty cool about this is that these little feet on both sides of the fan are a soft rubber, so that should cut down on some of the vibration and fan noise and stuff. So that's pretty neat. That's a nice little touch. I'm gonna go ahead and pop the screws all the way through and into the little threaded inserts down here. Well, other cool things worth noting about this radiator is the pump comes with this cool like little LCD screen. You can display like your fan speeds and your temperature and stuff like that on that. But this is removable. You can pull this straight up and take it off of the pump. So I'm gonna go ahead and remove that just so that during installation I don't accidentally scratch the little screen up. Also, I went ahead and put the anti-static bag that the motherboard came in. I went ahead and put that in here because this thing, with the hoses and stuff hanging on this is kind of a little unwieldy. So I don't want this to be bouncing around and scratching up the motherboard. So I put the plastic bag in here just to give it a little bit of extra insulation. And then we're gonna go ahead and mount that in and screw it in from the top. If we look on the bottom of this, we can see that a gray thermal paste has already been applied to the bottom of the pump. Here, my paste is still intact. I'm going to remove the protective plastic and then put this right down onto the CPU. The little plastic, or the little metal fins on here go attached to those 4 standoffs that we installed earlier. These fins are evidently not attached to anything. They will just slide right out, so be careful of that. And according to the instructions, the data port on this pump needs to be at the bottom of the case. So I'm going to make sure that I apply it in that orientation. It comes with these nice thumb screws. I'm going to do these just like we would with the lug nuts on your car. We're going to do kind of across diagonally from one another. Putting them on real kind of loose at first just to hold it in place, and then we'll go back around again in a star pattern, tightening them up the rest of the way. Don't over tighten things. With that now in place, I can go ahead and put the little LCD screen, just plugs right back into there like that. The last remaining steps here, we got to put the power supply in next. That's the last major component. After that, it's all about plugging in all of the cables and wires and doing our wire management. All right, here's the new power supply. Let's go ahead and take that out. It's pretty huge. Look at that, 1300 watts. That is just incredible. All right, let's go ahead and get this bad boy mounted. I just said that the power supply was our last major component, other than the wires and stuff, but I totally forgot. Some would argue that this is the most important part, the graphics card. Yes, RTX 3070 by NVIDIA. I am looking forward to this. Let's go ahead and unbox it, see what it looks like. This little guy, 3070, is 2 fans. This is a normal size graphics card. Looks very nice. It looks like it's put together really well. My last graphics card was MSI, and it has lasted. I keep transplanting it into my new computer builds and stuff, so it's lasted a very long time. So I'm been very happy with the MSI. So let's go ahead and get this guy mounted. This card is going to take up a lot of space in here. It's going to start getting a little bit difficult to get my hands around and work on things. I've been leaving this protective plastic on all the parts because I didn't want my screwdrivers and my other things as I was moving the big parts around to scratch anything up. So I'm going to go ahead and remove that plastic right now because it's going to be hard to get to later. So let's go ahead and take off all the protective things. This motherboard has several PCI slots. There's a Gen 5 here, a Gen 4 here, and then there's another Generation 4 down below. The video card that I have is a Gen 4 card. So the cool thing about Gen 5 is that it is compatible with Gen 4, backward compatible, I should say. So I can plug my card into either slot that I want. Just like with the RAM, there's this little lever here that you have to open to be able to slide stuff in, and then you push it closed to lock your card in place so that it doesn't fall out or whatever. This is something cool that this Asus motherboard has, is it's got a push button release that is located all the way over here. So you don't have to get your fingers underneath the card to reach the little switch. You can just come out way over here and you can push this little button to open the lock right there. So I think that's pretty cool. Well, let's get a close-up on this so that you don't make the same mistake I did. There is a protective plastic slot thing on this, so we have to take that off first. Voila, there are the contacts. So now it'll fit in the slot. It's time to start plugging in the wires and stuff, and just wanted to point out a few important things if you're new to computer building. I've said it before, consult your manual. There's all kinds of headers all over your motherboard, and you want to make sure that you're plugging the right thing into the right port. In some instances, the ports are keyed, so you can't plug in the wrong thing, but in a great many of them, it is entirely possible to plug in the wrong thing into the wrong port. So your motherboard is going to tell you what you need to do. So for example, the fans, they all use the same kind of port here, but the pump also has the same kind of port here. So you want to make sure that you're plugging your pump into the port that it's intended for, as opposed to just one of your fan ports. Now, not all motherboards have a dedicated pump header. Some of them use a fan header. Your motherboard will tell you that. So make sure you're consulting your manual so you know what goes in where. So here we're going to hook up all the wires that attach to the front panel. So this is like our hard drive activity light, power switch, things like that. So all these little plugs, here you can see I can pull this off. It says reset switch. It's got a positive and a negative on it. And on the motherboard, there's a corresponding place for that. And you need to make sure that you're plugging them in with the proper polarity. So here you can see there's a little minus sign on this leg and a little positive sign on this side. So you want to make sure that where it says ground, that's going to correspond with your minus sign. So with this power switch, since the minus sign is on this side, but it's on this side here, I need to flip that guy upside down. Now for a switch, that really shouldn't matter, but whatever, that's the way it's labeled, so that's what we're gonna do. For the hard drive activity light, you can see it's got a positive on this side and a negative on the other side. So here, hard drive activity positive, hard drive activity negative. So make sure that they are plugged in the right way or your lights won't work. This little dongle, I don't know if this came with the case or if it came with my last motherboard, but it's ingenious. I can plug all of these little guys, the power LED, the power switch, all these little things into this little header, and then plug this entire header right into the motherboard. I've already confirmed that the pin out for this matches the new motherboard, so this is ingenious. Every motherboard manufacturer needs to ship with this. It's awesome. I'm just going to plug this directly into the motherboard in the designated slots. If you don't know where it goes, consult your user manual here. It tells you where that port is located and the which one of those little headers is which. Here you can see I've got all of the case wires attached to the motherboard. So now we're going to start installing the power cables next. This power supply is really cool. It has it comes with a whole bundle of all different kinds of power connectors. And what's really neat is that they're labeled. It tells you like what kind of connector that is. So here you can see in this bundle we've got the adapters for the graphics card and stuff. Here's more plugs for the graphics card. So that's pretty cool. Some of the plugs, this one for example, this looks very much like the kind of plug that might go into your graphics card or your motherboard, and so to make sure that you don't accidentally plug the cable in backwards, it's actually labeled. This one goes to the power supply unit, so you don't get it the wrong way around. So this one goes into the power supply, and then the other end of those cables go to your other accessories and stuff. So that's really cool. I like that they do that. If I look at one of the cables from my old power supply, you can see that those are all not labeled at all. So you just have to pay attention to what you're doing. As a matter of fact, this is the only power supply that I've ever had that has labeled their plugs. So I really like that. That's pretty neat. For the most part, these are going to be keyed, so you're not going to be able to plug them in the wrong way. If there's any question, consult the user manual. It should tell you exactly what kind of plug your accessory needs, and then you can just find that plug and plug it in. So we're gonna go ahead and hook up all the power cables. Let's talk for a moment about the water cooler that I got for this build. This is the Corsair H100i Elite LCD. It's a water cooler. It contains a little LCD screen, and it comes with 2 or 3 fans for the radiator, depending on what size you get. Mine comes with 2 fans. So this has a ton of wires. Look at all this. Look at all this stuff. There's so many things going on here. What is all this? My last cooler, I plugged it into the pump header port on the motherboard, and that was it. There was only one wire to attach. But this one, it has all these RGB fans and stuff, and that's what a lot of this is, plus the little LCD screen. So there's all these extra things, and it took me a minute to figure out what exactly is going on here. So if you decide to get this cooler, let's talk about how this works. First of all, it comes with this controller unit. And you can see this side is labeled fans, and this side is labeled RGB hub. So if we look at all of these wires, these are all coming off of my 2 fans. So each fan has 2 wires attached to it. So one of them says to RGB hub, and then the other one, it looks like the other one just has some generic barcode label on it. So you can't mix these up because they're different kinds of plugs. They're keyed differently, so you can't mix them up. The RGB hub one, you plug that into the RGB side. The other one, you plug it into the fan side, and now your fans are good to go. So what is all this other stuff that's happening here? So since this does have a little LCD screen on it, you gotta have a way to control that. And the RGB lights in the fans are also adjustable, so you need a way to control that as well. So there's a plug coming out of the back of the little controller box that you plug into a USB port. Now if you look at this, this is not This is not a USB-A connector. This is meant to plug into the USB port that's on your motherboard. So if we look at our motherboard manual, this one can go into a USB 2. So we find that our motherboard has a couple of USB 2 headers on it, labeled number 10. So we just look around all the little numbers on the drawing here, and we find there, we see that we have two USB 2.0 headers we can use. Now one of them, my case is already plugged into one of them, so I have one port left. So I could go ahead and plug this wire that goes into the controller into that available port. The only problem is that this is for the RGB lights on the fans, and this other one is for the little LCD screen. So there are actually two of these USB ports that you have to plug in. Now thankfully this came with this little splitter device. So here I can plug in one USB port onto my motherboard, and then it gives me these two connectors that I can plug both of those two other ones into. So this will work out nicely. Just hook those up to the USBs. Now normally fans would plug into the fan headers on your motherboard, and that would supply power. It would also supply monitoring and stuff to make sure your fans are spinning. That way you'll get some kind of an alert or something if one of your fans fails and you don't notice it. For this one, the whole unit gets power from this SATA jack. So this is plugged into the controller, and you plug this into a SATA power port off of your power supply, and that will power everything. The last wire coming off of this is this ribbon cable. This one goes to the LCD screen. So this also plugs into the controller. So here on the end, you can see it's got a little jack pack right there that it plugs into. All right, so now that we have all of the wires figured out, we'll go ahead and route all those. This is a drive bay for like a small hard drive. I don't have a small hard drive to put in here, but I'm thinking I can go ahead and mount this guy inside of that and then slide it into its little drive bay home, and that'll hold this in place. I do notice there's no screw holes or anything to attach to this. But it did come with some double-sided tape. So I'll put some sticky tape on there and then slide the whole thing in. That'll kind of hide it because it's going to have all these wires and stuff coming out of it, be kind of ugly. So that'll help obscure some of that. So let's go ahead and put it all together. All right, the last wire that we need to connect is this little guy right here. This is connected to the water cooler pump, and it's a sensor wire. So if the pump were to fail or not be running at the proper RPM or something, then that little sensor will send an alert to let you know that there's a problem with your cooler. This motherboard has a header specifically for a pump, but that's only to be used if the motherboard was going to be powering the pump. This pump is powered by that little controller thing that we saw earlier. So since this is just a sensor wire, the instructions say that we're supposed to plug it into the CPU fan header instead. So on this motherboard, that is located right there. So let's go ahead and get it plugged in. There we go. We're all set. All right, it is the moment of truth. I'm going to connect the power plug here. I'm going to flip the switch. I see some lights. An exclamation point. What does that mean? Well, it's not on, so let's go ahead and turn it on and see what happens. Excellent. Nothing is happening. Well, we're going to have to look into that. I think I see the problem. Look at this right down here. Do you see that right there? That's my power switch jumper has come loose from its little socket. So that's why my power switch isn't working. I gotta plug that guy back in. I probably bumped it out when I was installing that USB port for the cooler. So I'm going to plug that back in, and then we'll try it again. We're going to try again here. So I've plugged that little jack pack back in. We're going to flip the main power switch on the power supply, and let's go ahead and hit the power button one more time and see if it works now. Oh, that's a good sign. Things are happening. Oh, look at that. That's a beautiful thing. That's magical. Look how pretty it is. Look at all those lights. I love that screen in there. I like it. And all this stuff is all configurable, so I'll be able to configure the LED on the RAM and the LEDs on the pump and the fans and all this stuff. So I'm looking forward to playing with all that. I'm going to go ahead and try and install the operating system. Let's see if that will work. So we've turned the computer on for the first time, and we're looking at the boot up screen here, and it's telling me that a new CPU has been installed, and I have to enter the BIOS setup. So I can press F1 to run the setup, and what I'm going to do is configure my RAM and my CPU and stuff. Now the first and most important thing you have to do is set the clock, because this is not the right time or date. So let's go ahead and configure that first. Now this little box right here says that XMP is disabled. What is XMP, you ask? I'm glad you asked. That has to do with our RAM. You can't really read that, but it says this RAM is XMP ready. This is fast RAM, 5200 megahertz, and XMP is what's going to allow us to hit that the full speed of the RAM. By default, that is turned off on, I think, all motherboards, and you got to turn it on if you want to take full advantage of your RAM's speed. So let's go ahead and turn that on. It has detected DDR5 5200, and it's got all the right timings and everything already put in there. That is amazing. Wonderful. I love it. I'm not seeing anything about the CPU. It says right here it has identified my CPU, a 13th gen i9 13900K, 5500 megahertz. It's got my 65 gigabytes of RAM installed. It looks like it's auto-detected all of the stuff. Here's an advanced mode down in the lower corner. Let's go ahead and tick that. Okay, here is something we definitely do need to look at. In order to install Windows 11, you need to have this secure boot thing enabled. It won't let you install it if you don't have this on. So here I've gone to the boot menu. I'm going to go to secure boot. I'm going to tell it that we're going to do Windows UEFI mode. Okay, so we've enabled secure boot mode so that we can install our operating system. All right, so let's go ahead and save our changes, and we'll see if we can boot off of our USB stick. This is a summary of the changes that we've made. We enabled the XMP on our RAM. That one setting alone made all of these other adjustments. And then we enabled secure boot mode so that we can install Windows 11. Time to download a copy of Windows. We're going to put it on a USB stick so that we can install Windows on the new computer. So I'm just going to do a quick Google search for Windows Install Media Creation Tool. Here it is, Create Installation Media for Windows. I run Windows 11, so I'm going to go ahead and select that option. Do make sure that you are actually on the Microsoft domain and not some other phishing website. I'm going to do this option here for the Windows Installation Media as opposed to the Assistant. This is going to let me install a brand new clean version of Windows. I'm not doing an upgrade or anything like that. So we're going to download this option. Here you can see the download has completed, so I'm going to click to open that file. This will run the installation tool, and the installation tool will create the bootable USB drive. And we'll just step through the wizard, accept the license, blah, 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 all that stuff. I'm going to select the option to create a USB flash drive. I have two currently plugged into the computer, so I'll choose which drive I want to use. So at this point, the computer is creating the bootable USB drive. It's downloading a copy of Windows, or the install package anyway, putting it on the drive, making the drive bootable, all that good stuff. We'll just put the drive in the new computer, turn it on, and it should boot right into the installation program. All right, the computer is now rebooting. And sometimes we have to press a key if we want to boot off of the USB drive, so I'm going to be looking out for that. I may need to go into the BIOS again and tell it to boot off of the stick there. I think we'll go ahead and do that actually. I'll press delete and F2 to enter the setup. And then we're going to, right, here we go. Here it is. Partition 32 gigabyte. That's my USB stick. That's the one that should have the operating system on it. So we're going to change our boot order. I'm going to drag that up to number 1, and then we'll save and exit. Let's see if it boots off the stick now. Oh, wait. Aha, it did boot off the USB drive. There it is. Okay, so we're going to go ahead and set up Windows. This is pretty straightforward. We're just going to go ahead and answer the questions. So here I'm reinstalling my copy of Windows, so I'm going to choose this option. It says to select I don't have a product key. Your copy of Windows will be automatically activated later. So what I'm going to do is I'm going to port my license from my old computer over to this one since I'm no longer using the old computer. If I'm not mistaken, I had Windows 11 Pro, so let's go ahead and install that one. I'm going to do a custom install so that I can completely format the hard drive and get a clean installation. My primary drive is the 1 terabyte drive, so I need to identify that drive and format it. So here I have drive 0, drive 1, and drive 2. So I've got 3 drives in here. I've got the 1 terabyte Samsung drive. I also have a 230 gigabyte Samsung Evo drive, and then I have an older solid state drive, 500 gigabytes. Drive 1 is my 1 terabyte drive that I want to install the operating system on. So what I'm going to do is go ahead and delete these partitions and then recreate them. So let's delete this one. I'm going to delete all of the drive 1 partitions. All right, so now drive 1 is just 1 terabyte of unallocated space. We're going to go ahead and tell it to create a new partition there. Turn that up as far as it'll go. It's already on maximum. We want to use the entire space here, so we're going to apply that. To ensure that all Windows features work correctly, Windows might create additional partitions for system files, and that's what we saw before. There was a whole bunch of partitions on there. Windows does that. I don't know why. I'm sure it's got its reasons. Here, drive 1, and drive 1. So it's created 3 partitions, and they're all small. Here's a 100 megabyte, here's a 16 megabyte, and then the majority of the drive is right here. So that is the drive that we're going to install Windows on. So let's go ahead and hit next. And it's going to copy the files and do the stuff. So here it wants me to sign in with my Microsoft account, and I do want to do this because my license is on my Microsoft account. So I'll go ahead and type in my information. I'm going to go ahead and set this up as a new device. All right, Windows has completed its little initial setup stuff. I'm going to check Devices, Device Manager. So in Device Manager, what we're looking at is we want to see if there's anything with exclamation points. That's going to tell us that that those devices aren't installed, their drivers aren't installed. So to get rid of those exclamation points, we need to install the respective drivers. So what we're going to do is we're going to do a Google search for the motherboard type that we have. We're going to go to the motherboard's website and we're going to look for the support section. What we're looking for specifically is the driver download page. So here on the support page, you can see there's a tab here for drivers and tools. I'm going to go ahead and click on that one. On this, I have to select what operating system I'm using, Windows 11 64-bit, and then here's all of the different drivers that that are available for my motherboard. So what we're going to do is we're just going to download each one of these files and then run the installer. It's pretty much that simple. It should automatically fix those exclamation point issues for you. So there you go. You now know how to build your own computer. I hope that this video was helpful. If so, please consider liking and subscribing. And don't forget to leave me a comment down below as well.